Good morning, I'm Cody Hendrickson. Today we're going to be talking about how we can work with math in Java and what we have to do to make it so we can do some of the more features with that, and you can use the same kind of problems you do in your math class and talk about that using a computer science to solve those problems using a computer. The big thing you have to remember is when we're talking about order of operations, the standard order of operations you know and love from your math class still works the same in Java land, just like it does in math land. It even works the same in Swift land too. But there are a couple things we have to keep in mind that we do a little bit differently. So some of the more complex or advanced topics, like functions and stuff like that, those can be done using methods rather than simply just an operator like you'd normally do inside your math class. But we'll see how we can easily do that in Java as well. Order of operations, though, works the same. Key point. A quick reminder that when we're talking about writing out larger values in Java, if we're writing this out on paper and we're doing this for a math class, we use if we're in the US, we'd use a comma to separate groups of 3 for the powers of 10. If we're over in Europe, we use the decimal to do the same thing. But we don't have that luxury to do so in computer science land because commas and decimals mean something totally different when we're talking in code land. So instead of using that, we can separate larger values by use of the underscore. The underscore can split apart values and make it so it's very easy to identify, oh, that's 1,123,000 right there. And we can, without having to have the underscores on that, it might be a little bit harder to read that value as a human being would and have to count out the different values, especially if it's a little bit tiny font, something like that. This makes it so it's very easy. You can separate, that out and read to what you're actually putting in, especially when you're defining values for, say, for example, a variable you want to execute information upon. The same approach works when we're using with doubles as well. I can put these underscores at any point. I simply use the 3 spots because that's how we work with it when we're doing math in the US, is every, we have the tenths, hundredths, thousandths, 10,000th place would be that spot right there. So we have the separator right there. We could keep track of it and understand where we're going for that. And so the same thing approach works when we're talking about using in Java to write those out so we can better read them as a human being. It doesn't hurt the compiler at all. It just makes it easier for us humans to read them. An important thing to remember when we're doing Java math is that we have to remember that when we're working with primitives, primitives always get copies of values. So your original value is unchanged. It's not like, say, for example, you have a variable in your math and you can just blah, 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 blah. The variable, when you're talking about that, you can only change the contents of a variable in Java land with the assignment operator. So if you have a variable, you define it to be something, and you send that variable off to a method, it doesn't change that variable. It gets a copy. So you want to make sure that when we're working with primitives, we remember that anytime we send a parameter to something, we're giving it a copy when it's talking about primitive land. So if I give a method a parameter of a primitive, that is just a copy of the value, not the actual object or the original one you're working with. In Java, everything beyond add and subtract, multiply, modulo, and divide are handled with the use of the math class and the math.methods. You can use a static import, so you can simply just call the method name, but I myself always like to call math dot and whatever method we're working with. Some of the common methods we have math.pow. We pass it as its first parameter, the base, and then the exponent that we're going to be sending it to, and that returns a double value. We have math.squirt. Again, this goes back to the fact that when we're going back and we're using that previously to Java and in earlier computer science land, we were limited on the number of ways we could actually write out things. So we take out the vowels, we condense the concept, and so square root becomes squirt. So we can have that. We take the number we're going to take the square root of, and it will return that value. We can even do square roots using the math.pow function and pass it a decimal value of that exponentiation. So we can, I want the half root, the cube root, etc. So I can get 1/3 right there would give me the cube root of that because that would give me what that power would be. Math.random gives me a random number from 0 up to but not including 1. We'll have a whole series of lectures and use on that, but just a quick reminder on that. One of the really important ones we want to make sure we remember are math.max and math.min. Math.max, you have 2 parameters, it returns the bigger of the 2. Same thing with math.min. 2 parameters returns the smaller of the 2. And you can use these 2 functions in conjunction to solve a lot of problems rather than having to go through and check things out. You can simply use the math.max, math.min to figure out what that's doing. One of the great examples of that was the trio question for the AP exam, where you had to figure out the smallest of the 3 prices. And you can use that information to go from there. One more thing we have to remember when we're talking about doing Java math is we have to handle casting. Now, if we use a plus equals or a minus equals, times equal, divide equal, casting is automatic and implicit and it handles it on its own, but we generally have to cast by putting the type inside parens of what the math we're doing so we can make that happen. But we have to realize that when we're doing casting, information is changed. If we're casting from a double to an int, we lose all of the fractional information, the decimal precision, so 0.00009 or 0.99999 or 0.909999999, all that, everything after the decimal is lost. That precision of information is totally lost when we're changing from a double or a floating point value to an integer value. If we're going the reverse, and we're changing from an integer value to a floating point value, from int to a double, we're going to gain a 0.000 something. aka we don't gain very much. And so we gain not a lot of information when we change from int to a double, nothing very helpful. But when I change from a double to an int, I lose information. And it's very important that you keep track of that when we're doing Java math problems, because it can actually change the results of your equation or what you're trying to solve if you don't keep that in mind. So again, just a quick review. When we're casting, we have an information change. We lose it for going from double to int. We gain almost nothing from going int to a double. All of the cool functions of mathematics, things like, sine, cos, tangent, cotangent, arctangent, all that fun stuff, all those exist in the math library. We access it by going math dot and the method name we want to call. And most of these are shortened down, so math dot pow is how I handle exponentiation, the base and then the exponent, squirt, random. The two really helpful ones, math.max and math.min. These can all return values we can work with and handle, and you're probably going to be casting them from doubles to ints as you work along with them. And those just, but there's a whole bunch more beyond this, but we can do more with it. And these are the ones I really want to make sure you know and use. Quick reminder about parameters. When we're giving a primitive parameter, we always get a copy of that value. The original is unchanged because primitives are free basically in Java. And so when we're handling that, anytime I send a copy of, anytime I send a primitive as a parameter to a method, my original value is unchanged. I get to hold on to it and hold it all for my own. But when I give it to you, the method, you get to change and manipulate it for yourself. It's only if you use the assignment operator to give it back to me that I can change my original value. So primitives are I get a copy. The original value is unchanged. In math problems, we often need to use larger values. We can handle that by separating them out by use of underscores, since we don't have the use of a decimal or a comma like we do in either European or American systems to separate groups of values. We use the underscore to make that so it's easier to read and write and understand what our values are when we're trying to explain something, for example, a larger or bigger value that we want to represent. Underscores are how we separate those on there without hurting what's inside the actual value itself. Finally, again, a reminder, when we're talking about order of operations, the foundation of mathematical logic, JavaLand and MathLand, they're basically the same. PEMDAS works in both directions. You just have to remember to keep in hand for modulo so you can do the remainder division. Thanks again and have a great day. We'll see you later.